Practice 6 is solid cementation, quench, and temper. The main objective is to apply cement carbon steel to increase the mechanical properties of the out layers. Also, they analyze the effects of the cementation.
For this practice, we're going to use a steel 1018, a protective equipment, a furnace, an iron box with lid, and equipment for metallographic preparation.
First, we crush the coal and then we apply the substance to the box that is between 83 and 87%, and in decimal is 0.1653 kilograms. Then we apply sodium carbonate between 2 to 3%, that in decimal is 0.0052 kilograms. Then we apply barium carbonate between 10 to 12%, and decimal is 0.0228 kilograms. And finally, we apply calcium carbonate between 3 to 4%, and is 0.0076 kilograms. Then when we have the mixture, we apply it a bed in the box, and we apply the three pieces that we cut, and then we fill to the top with the mixture so we can sell it with the clay.
After sealing the box with clay, we will start the heating of the muffle, which will take about 2 hours to reach the desired temperature. After that, we will give the heat treatment to 3 pieces, which will be at 900 degrees Celsius for 12 hours. After that, we will quench one of the pieces, and the other two are going to be heated to the crystallization temperature, which is 800 degrees Celsius. One of those pieces that we quenched will be tempered for 15 minutes at 200 degrees Celsius.
On the TTT diagram, after putting the pieces on the furnace and waiting for 12 hours at 900 degrees to make austenite, we quench the box, the pieces, and then we reheat at 800 degrees for 15 minutes, where the crystallization occurs. Then we quench again the pieces, and then we temper at 200 degrees for 15 minutes, where we obtain the martensit. Then we just wait so it cools to room temperature.
We can confirm that, depending on the heat treatment of each piece, the mechanical properties improve by each piece, and also compared to the original sample of the steel, which is 1018. To determine the differences in the mechanical properties of each piece, we used two methods. First, we did the Vickers hardness test on each piece, and after that, we did a chemical attack to determine the ASTM grain size. On the first piece, we had a Vickers hardness of 196. On the second, 199.5. And on the third, 206.5, indicating that each piece with the different treatment has different mechanical properties. And the grain size of the first and second piece were both 9 and the third one was 11. On the grain size, we think that maybe the chemical attack was not properly done, because theoretically the grain size of the second piece should be greater than the first one.
Cementation is a process in which carbon is added to certain steels to increase their mechanical properties. It is an obsolete process nowadays in the industry, but it is still used to create axles and cams. It is also used to create and produce tools that are going to be in a constant work where cracking is possible to happen. The steels that are going to be in the process of cementation are those ones that are really soft. There are three types of cementation: liquid cementation, gas cementation, and solid cementation. In the liquid cementation, there are used molten salts rich in carbon. In the solid cementation, we put the pieces into a steel box, into an iron box with many substances rich in carbon. And in the gas cementation, we use propane or natural gas, and that is the most efficient process of the three, and it is used in pieces with high consistency.
Well, there are three types of furnaces that are used in the industry for cementation. These ones are submerged furnace, semi-finished mufflers, and the mufflers that has an electric resistance. Well, carburization is the process that is essentially adding carbon to the surface of the piece in order to make it stronger, and cementation is a heat treatment in order to make harder the piece that we are working to. Our steel is an hypotectoid steel, so it is before or left in the hypotectoid reaction. So this is a iron 10, 18. So there are two solid phases that are ferrite and austenite. So the summation of these two ones becoming to perlite, that it is the hypotectoid microconstituent, and the primary is the ferrite.
To determine the depth of carburized layer obtained after cementation, we have to use the diffusion formula. Having the amounts of carbon in the atmosphere of the furnace and the type of steel, we get as a result 0.911. The value for the ERFZ is equal to 1.2, which is obtained in the tables, such as the Q, that is equal to 32,900 calories per mole, and the constant of diffusion, which is 0.23 square centimeters per second. Once we calculate the value of the diffusion, which formula is D equal to the constant times E elevated to the Q over R and the temperature in Kelvin. Once we calculate, we obtain a value for D of 1.703 times 10 to the minus 7 square centimeters per second. With these values, we can obtain the value of x from the formula ERFZ equal to x over 2 times square root of D times the time. As final result, we get a value of 0.2 centimeters of depth.
It is important for us mechanical engineers to understand how the cementation works so we can use it on the industry based on the carbon that is placed on soft steels and how it gets harder on the edges and soft on the inside. Yeah.
It's important to know how is the process of cementation so we can know how to apply more carbon to a material. In this case, our material is steel 1018, so this can help us in future projects.
Knowing the differences in the mechanical properties of materials that have been carbonized is important because depending on their mechanical properties, we can use them in different applications. It might be a long process, but at the end it's worth it.
Well, my conclusion of this practice is that there are some heat treatments that help us for, well, in order to make harder our pieces and our materials, and this is convenient for us in order to apply it in some projects in the future and know better how the carbon helps us to make stronger the pieces during cementation.
As my conclusion, I think that this cementation process is really important. We have to know how to do it because this process can help us to improve our materials with better mechanical properties, and in our tools it can give us a better performance.